Hello, grade 9 students. How are you today? Today we are going to continue our lesson Trigonometry in a Right Triangle Part 3. At the beginning, we are going to discuss the fundamental relations between the trigonometric relation of an angle. Let ABC be a right triangle at B and an acute angle ACB, which is called alpha, and alpha is measured in degree. So we can express the three trigonometric relations sine alpha and cosine alpha and tangent alpha in terms of its sides. So sine alpha, as you know, is to divide the length of the opposite side to sine alpha by the hypotenuse, which is AB over AC. Cosine alpha is to divide the length of the adjacent side to sine alpha to the angle alpha by the hypotenuse, which is BC over AC, and tangent alpha is to divide the length of the opposite side by the adjacent side, which is AB over AC. Now let's calculate the square of these trigonometric ratios. Sine alpha square is written as sine square alpha, which equal to AB over AC all to the power 2, or AB to the power 2 over AC to the power 2. Cosine alpha square, it's written as cosine square alpha, which is equal to BC square over AC square. If we add the two squares together, we get, if we add sine square alpha plus cosine square alpha, which is equal to sine square alpha is equal to AB squared over AC squared, and cosine square alpha is equal to BC squared over AC squared. So we have here a common denominator, which is AC squared. By adding AB squared plus BC squared, what we get? If you see in a right triangle, AB squared plus BC squared is equal to the hypotenuse squared, which is AC squared, by using Pythagorean theorem. Now, AC squared by AC squared is equal to 1. So we can conclude that sine square alpha plus cosine square alpha is equal to 1. This is the first rule. Now, if we divide sine alpha by cosine alpha, sine alpha is equal to AB over AC, cosine alpha equal to side BC over side AC. If we calculate this ratio, we get AB over BC, which is equal to tangent alpha. So rule 2 is tangent alpha equal sine alpha over cosine alpha. How to use these two fundamental relations? The two rules can be used to find the two trigonometric ratios of an angle if the third is given. Always remember these two rules: sine square alpha plus cosine square alpha equal 1, and tangent alpha equals sine alpha over cosine alpha. Example 1, alpha is an acute angle such that alpha equal 1 over 2. Find cosine alpha and tangent alpha. Here we want to calculate cosine alpha and tangent alpha. First, find cosine alpha. Using the trigonometric ratio sine alpha square plus cosine alpha square equals to 1. We put sine alpha, which is 1 over 2, all to power 2. 1 over 2 all to power 2, which is sine square alpha, plus cosine square alpha equal 1. Here the unknown is cosine square alpha. By calculating this relation, we got 1 over 4, which is 1 over 2 to power 2, 1 over 4 plus cosine square alpha equals 1. So cosine square alpha equal 1 minus 1 over 4. So cosine square alpha equal 3 over 4. To calculate, this is cosine square alpha. To calculate cosine alpha, sure, it gives radical 3 over 4, which is give plus or minus radical 3 over 2. Then cosine alpha equal radical 3 over 2. Now, we want to find tangent alpha. We find cosine alpha, and now we want to find tangent alpha. We use the rule tangent alpha equals sine, which we have, and cosine, which we calculated. So tangent alpha equal 1 over 2 divided by radical 3 over 2, which gives 1 over radical 3, and by rationalizing the denominator, Multiplying the numerator and the denominator by radical 3, it gives radical 3 over 3. Relation between the three trigonometric ratios of two complementary angles. In this triangle, right at B, A and C are two complementary angles. If we add angle A and angle C, it will give 90 degrees. The three trigonometric ratios of this angle is, first angle C, we'll start by sine C. Sine C equals opposite by hypotenuse, which is AB over AC. Cosine C, which is equal to the length of the side of the adjacent by the length of hypotenuse, which is BC over AC. And tangent C is equal to opposite by adjacent, which is AB over BC. On the other hand, let's calculate the three trigonometric ratios of angle A. So cosine A equal to the length of the side adjacent by hypotenuse, which is AB over AC. As you see here, sine C AB over AC equal to cosine A. Now sine A equal opposite by hypotenuse, which is BC over AC, and tangent A equal length of opposite over adjacent side, which is ABC over AC. You should notice that sine C equals to cosine A equals to AB over AC. And cosine C, which is BC over AC, equals to sine A, which is BC over AC. And also, tangent C is equal and tangent A are reciprocals. If you see here, tangent C and tangent A are reciprocals, should tangent C equal 1 over tangent A. So the rule states that if x and y are two complementary angles, then sine x equals cosine y and cosine x equals sine y. And tangent x equal 1 over tangent y. In this example, as you see here, angle 30 and 60 are two complementary angles. Their sum is 90 degrees. So cosine 30 equals sine 60 and sine 30 equal cosine 60. And tangent 30 equal 1 over tangent 60, as you see. Let us solve some example together using the two fundamental relations of trigonometry to prove some relations. First example, show that 1 plus tangent square x equal 1 over cosine square x. First, you know that tangent alpha equals sine alpha over cosine alpha. Then tangent square x, you can substitute it by sine square x over cosine square x, or to the power 2. So 1 plus sine square x over cosine square x by reducing to same denominator. And don't forget here that in such equation you can work on one side or both sides by replacing the values and by reducing to same denominator. So cosine square x over cosine square x plus sine square x over cosine square x. We take cosine square x as same denominator and we add the numerator, which gives cosine square x plus sine square x over cosine square x equal to 1 over cosine square x, which is true as the relation above. Example 2, show that cosine x times tangent x equals sine x. The solution is to substitute tangent x by sine x over cosine x. So the relation will be cosine x multiplied by sine x over cosine x will be equal to sine x, which is true as the relation is given. Example 3, show that 1 plus 1 tangent square x equal 1 over sine x. As you know, we can replace tangent square x by sine square x over cosine square x. So the relation is 1 plus 1 over sine square x over cosine square x. By solving this compound fraction, we get 1 plus cosine square x over sine square x. We can solve these two fractions by reducing the common denominator, which is sine square x, and then sine square x over sine square x plus cosine square x over sine square x will give sine square x as a common denominator, and we add the numerators. So sine square x plus cosine square x, what does it gives? Sure, it gives 1. So the answer will be 1 over sine square x, and the relation is true. Thank you guys, and stay safe.